Hey folks, Rob here. I'm an architect, and I want to share with you some of my process and my current mission to create a drawing set that can easily be edited by a new intern or employee. So at this point, I'm showing you my title sheet. I've got down here 9 sheets. I'm trying to kind of keep these short, these drawing sets as short as I can. I'm including structural information on 3S sheets, and the structural information is coming direct from the Oregon Residential Specialty Code, with some tables adapted and things like that. So kind of getting right into the title sheet, we have our general notes, architectural abbreviations, symbols. It's kind of a map through through our set. Here we've got the site snip and site map, or vicinity map and site map. These you get directly from either Google Maps or your jurisdiction maps URL or website. And then here's kind of the project information, and architect, owner, site description. That comes from the jurisdiction site information. Jurisdiction is the county or city that your project is in. Trade permits, those are always MEP. Got a few general notes here. My sheet list telling you how many sheets and what the sheet names are. Code analysis through ORSC, and generally I just cover the section, the 300 section there, and the rest is kind of in the drawings. Here's our energy efficiency schedule or table, showing insulation and fenestration, HVAC, lighting, that kind of thing. So trying to cover those bases here on the title sheet. You've got your name, your owner name, your project address. You've got to have a stamp on there. Actually, you don't, but I am a licensed architect, so I've got to use my stamp. Here is the stamp for when this drawing set is, what the status is, schematic, and then what the date is, in terms of when you're submitting for either a review from the client or a review from the jurisdiction. Right now I have my 100th birthday in there just as a placeholder. Hopefully I'll get there someday. Well, on that day. Here's our site plan. Scale of this is, well, it should be in the right here, 1/8 inch. That fits pretty well on a single sheet, plenty of room. Here we don't actually have a site drawn in. I just have general annotations and my, model footprint in here. So that's a live model inside the site plan. We've got some annotations, and what I would do is bring in a tax map and also a Google map and scale it as close as I can to the scale of the drawing, and then draw, line work over it to clarify important items such as, where electricity comes in, where plumbing comes in and out. That's, fresh water and sanitary, and your existing building footprint if there is one. Other important site information. Ideally, you get a what we call a survey from a surveyor, a site surveyor, with some information on topography and existing conditions of the site. But you can kind of create your own as an architect with Google Maps and a site visit. Getting to the 3D views, again, this is a placeholder model or a previous project that I've stripped down to basically nothing, except for a few walls. So here we'd have 3D views of our project. Jumping into proposed plans at this point, we've got our floor plan, first floor plan. This is an ADU, so a single-story ADU. All we need are basically 3 plans. If it were 2 stories, we'd need 4 plans. 3 stories, we need 5 plans. So first floor RCP, well, actually, RCP is for every floor as well. So, but only 1 roof plan. So, you've got to add 2 more plans for every floor that the building has. So on my floor plans sheet, I've got my room schedule, keynotes, keynoting, denoting or annotating all of the various things within the plan, door schedules, some abbreviations for the schedule. We don't use full words in schedules. They'd be too large for the sheet. Some legend information, outlets, walls, wall types, and RCP legends, so lighting, switches, that kind of thing. Outlets typically go on your floor plan, where switches go on your reflected ceiling plan. And we have no roof on the project yet, so all we're seeing on the walls here. Jumping into elevations, you've got your exterior elevations. We have to show fenestration or opening and window areas, and that they meet our requirements from the residential code. You need a minimum of 12 or 14%. Check your local code for that. I have my sections on my elevations page because there's room. Typically these go on their own page, maybe with an enlarged wall section. And also our interior elevations, showing bathroom elevations that are important, as well as kitchen elevations that are important, I've included on my exterior elevation sheet because I have the room. And I've also included my window schedule on the elevation sheet because you see the windows on the elevations. And here are annotations, keynotes, which touch all of these drawings basically. What I do is, change the change from 1 to 10 to 20 to 30. So in groups of 10 per view type. So for the elevations, I use 1 to 10. Sections, looks like I'm using 10 to 20, and interior elevations, 30 and even up to past 30 to 40 there. To details, these are all project specific, but I've got a live detail here for my wall section, from which I'm pulling drafting views of window head and sill. Those are pretty typical, except for your exterior finishes, be that stucco or lap siding, whatever your client wants. Here's our floor assembly. In this case, 4x8 girders with 7/8 tongue and groove plywood. You've got to have a door sill, your exterior door sill, because we need water to shed away. And one of the big things architects show is how water is shedding away from a building. So zooming in here, you have flashing underneath your trim, some caulk there at where the trim meets the siding. You're showing your weather-resistant barrier. That's important to specify in your project. And your basic wall assembly at the window head there, we've got to show our header, but that's going to be per structural. Here's our high eave. This is a monoslope project. This would probably come out for the next so this is a project template that I've created. So some of these details won't apply to the next project that we build into this template. Jumping into structural, I've got my general structural notes that I've kind of worked into my drawings based on experience. So we've got general structural specifications here, which you're going to need if you're specifying structural elements of your project. This is a nailing or fastening schedule coming directly from the Oregon Residential Specialty Code, and structural symbols here as a map on how to read the drawings. Here we have general site-specific data, loading of your roof and floor, wind, snow, seismic, and got your roof average weight of materials and wind loads here, which all play into how we look at hold downs for the ceiling assembly. And these change per depending on where you are in in your state. Wind loads change depending on elevation and other factors, and you get that information from your residential code. Um, so that is your basic structural. Jumping into structural plans, I've only got one floor plan or one floor in my project, so a single floor plan is fine. You have a brace wall plan, which you would have to have for each floor as well, and then your roof plan. So this is your roof framing plan. We're going to show joists here drawn in. Floor plan as well, showing your joists or girders drawn in, your spans and your limitations based on span tables in the residential code. Brace wall panels are minimum 24 inches. That line should be at the corner of the building there, and you have to check your brace wall panel section in your residential code to determine exactly what those. Choose your brace wall panel type and figure out how much space you need on your walls. So you really do need to have some sense of this brace wall panel length requirement before you place your windows. But to be safe, at least give yourself 2 feet from your window to the edge of your building. Though there is a rule where if you have a hole down there at the end of the panel, you can have a window closer to the corner or even at the corner of your structure if you're doing a continuously sheathed wood structural panel, abbreviated here. So here's my brace wall panel table, which I sort of adapted or created using the structural code, residential specialty code, but the structural portion of that code. It's kind of a map logic saying, well, wind doesn't apply because seismic takes precedence. So you use the seismic table. You look at your building height and other things to kind of create this table. So you have to check this table and create a new brace wall panel length portion every time you have a new project here, because these are going to change. Your brace wall panel or your brace wall length will change because your building won't be just 22 feet long as this one was. Again, this is a template created from a project that I just finished. Here's some notes in your brace wall panel schedule, some structural keynotes. I like to align the edges of things, so I'm going to go ahead and do that. And I'm not exactly sure how that became unaligned. I think I just clicked on it and accidentally moved it as I was adding these stamps. So all these red stamps are for the draftsman to be sure to kind of do the minimum amount of work to make these drawings make sense per the new design that's going into this model. Wall schedule just showing spacing of studs, size of studs. And this is really a bearing wall schedule. I should probably call it that. And it says see brace wall panel schedule, which is here. And so typically our exterior walls are brace wall panel walls, especially in a continuous sheathed brace wall panel wall. The whole wall basically is acting like a brace wall panel. So again, your floor structural plan or floor framing plan, your brace wall plan, and your roof framing plan. And then getting into structural details, here I've got a bunch that probably only apply to this project. So we'll probably end up deleting them unless we do have an exterior post, which these two details, well, this detail and this detail are talking about or showing. And so, these are your basic foundation, pier foundation, sorry, not pier, but, post and beam foundation in a crawl space, which is a nice way to build a house. And you've got your basic foundation, anchorage, and hold down and rebar requirements when you have a retaining wall or stem wall. That's derived from the Oregon Residential Specialty Code as well. These are derived from details drawn in the code as well. This is interpreted from um, my builder. He likes to do a pocket beam in a 6-inch concrete foundation wall, and so I've created this detail for that portion. And this is our brace wall panel assembly, which generally shows how a brace wall panel is put together, and blocking at the rafters is part of that. And that's really the reason I drew this detail. Everything else is basically described elsewhere, but the blocking was not. And I figured, well, if I want to show the blocking, I might as well draw the whole detail there and just clarify that construction. That is basically all I've got for you. So that's where I'm at. I'm hoping my new intern can open this template, understand the things, the really important things they need to check on and change. And of course, their main job likely will be to start modeling the project and designing the project. And so click on your floor plan views. You might not want to work in this view to start. You might want to create a new view or look for a working view. Here's our first floor working. There's some line work here that we can probably get rid of, and start here and say, okay, what is our building footprint looking like, and also you really want to look at your site and kind of coordinate between your site specific variables and your client requirements to create your initial floor plan. All right, thanks so much for watching. Let me know if you like the video.